Well, good afternoon, everyone, and welcome. Thank you for joining today for this Climate Central press briefing on the extraordinary week of weather we're having across the US. Over the next 30 minutes, we'll take a closer look on what's driving the record-breaking heat, wildfire smoke, flash flooding, and active monsoon conditions affecting communities from coast to coast. We'll also explore how these events are connected, what the underlying weather patterns are telling us, and the role of climate change. We're fortunate to be joined by two of Climate Central's experts, Shel Winkley, Climate Central's chief meteorologist, and Tom DiLiberto, our media director and also a meteorologist. After their remarks, we'll open the floor to questions from members of the media. You'll see in the down below, you have a QA button. I'll help to sort through those and get all your questions answered. This is also recorded, so we'll share everything with you afterwards. And yeah, from there, I'll let Shel take it.
Okay. Thanks, Abby. Howdy, friends. Shel Winkley. Good to have you with us on this Friday. Promise to get you in and out here in about 30 minutes, but we just wanted to help you kind of make sense of everything that's happening, show you what has been weather, and then what the influence of climate change is on everything that we've experienced this week, all tied around one big heat dome between the heat, between the smoke that it's experiencing across the northeastern US that's really bringing that hazardous air quality to millions of Americans, and then the flooding that we're experiencing in the southern US, specifically here in Texas. So let's start first with what's driving all of this. It's a big heat dome. We've seen several of these pop up throughout the summer. We had one really big one kick on over the eastern US over the 4th of July weekend. We've had several set up over Europe this summer so far, but this is probably the biggest one and the most substantial one that we've seen so far over the US this year. This is a look at where that heat dome is, kind of centered around that what's called a pressure line, a 597 line, where you see that. That was the core of this heat dome just a few days ago. So what happens underneath that heat dome? Basically, think about the atmosphere as being pushed down on. It's sinking. And so what that does is it inherently raises temperatures. This isn't new. We see heat domes during the summer months. We see heat waves during the summer months, and we expect this kind of weather pattern to exist. But what we understand with high pressure and heat domes with climate change is that they're becoming more frequent, much like what we've seen this summer so far. They are lasting longer and they are becoming more intense. So to start along with the heat, we did an analysis earlier in the week to kind of really understand what is climate change's role. So this is our climate shift index. This is Climate Central's attribution science, basically to understand, is this just summer heat, or is there an influence of climate change? And in this animation that you see starting Sunday, especially over the Western US, where you see those darker maroon colors, that's where we had a climate shift index of 5. Essentially, when you get to a 4, that means this heat would have been rare without a fingerprint of climate change. And when you get to a 5, that means that it's almost virtually impossible without human-caused climate change. And that includes things like the all-time record high of 109 that was experienced in Salt Lake City at the beginning of the week. So between July 13th and July 15th, 118 million Americans experienced at least one day where they walked outside their door to temperatures that were made at least 3 times more likely by climate change. Essentially, what that means is there was a very strong fingerprint of climate change on the heat we experienced in the Western US and then across the northern tier of the US this week. So that heat dome basically started bringing those temperatures that we know had a fingerprint of climate change. And really, that was the big story as we started our week. But along with this high pressure system, there's a clockwise flow around it. And what happened early in the week is we started to see an explosion of fire weather and wildfires begin to occur in Canada. And then that wildfire smoke come around the northern edge of that high pressure, drifting and lofting that wildfire smoke into the northeastern US. With that clockwise flow as well, that southern branch, this is where we're going to get into the flooding in just a bit, that's happening in Texas. But before I pass it on to my colleague, Tom, I wanted to show you that climate shift index for Monday over Ontario, where we saw a flurry of these wildfires kick up, where a lot of this wildfire smoke that has made it into the northeastern US It's pretty much not just because of, but mostly because of this cluster of fires. And what happened here in Ontario on Monday, temperatures were around the upper 90s to about 100 degrees. That's 25, 30 degrees Fahrenheit above average for this time of the year. And again, looking at that deep maroon color, Tom, that's a climate shift index of 5. So we know that the temperatures that occurred as these fires began would have been virtually impossible without human caused climate change.
Yeah, Shell. I think it's an important part to note. And you can see this next slide here is kind of overlaying now the CSI that Shell is talking about, along with fire locations. And you can basically almost track where the CSI was to where fires have been, not only in Ontario, but you can stretch as far up to the northwest too. And again, if you remember when we had when Shell was showing those wind patterns, you can see how wildfire smoke in that individual region will be able to be pressed down into the across much of the upper Midwest and getting into the Northeast as well. Now, climate change is not lighting the fire, right? It's not lighting the spark for these wildfires, but what it is doing by increasing temperatures and it's creating more fuel and creating the conditions where all you need is a spark. It's this idea that in order to make cookies, right, you need the ingredients for cookies in your pantry. What climate change is doing is stocking the pantry and it's preheating the oven. It's a lot easier to have wildfires because of this extra heat in the atmosphere. And this is just a look again, July 17th, at the active fires across much of Canada right now. There's a lot going on. It has been hot and it's been dry. And this is a story that's not just a this year story. This is now seemingly a repeat story that we talk about every single summer, where we have continued dry conditions, continued hot conditions, just waiting for a spark to have these wildfires. And then this is the end result if you have the atmospheric pattern set up in a way where you can now have that smoke travel thousands of miles. This is a satellite shot from yesterday, taking a look of all of that dusty stuff is smoke. That's smoke. So it's drifting down from Canada, reducing and making air quality incredibly poor across major cities, including Madison and Milwaukee and Chicago and Toledo and Cleveland, getting into now New York City, Philadelphia, and Washington, D.C. as well. So millions and millions of people are now being impacted by this wildfire smoke. And again, this is something that if you had asked people in a lot of these places along the East Coast, do you remember this happening a lot when you were a kid? They would say, no, I don't remember ever seeing this sort of happen. This is now multiple consecutive years, or 2 out of the last 3 years, where people have experienced now going outside, let's say in the Northeast, and seeing wildfire smoke coming from the burning of forests in Canada. This is from ECMWF taking a look at the animation now of that smoke. This is not only the observation, but getting into a little bit of the forecast. And you can see again all of those orange kind of like spires or where there were fires, and you can see how all of this is like a conveyor belt of smoke, all set aside by that heat dome. And that's the main reason why we're seeing all of these conditions. And again, this was taken earlier today, looking at the air quality in a lot of these places where that darkish purple is hazardous. It is dangerous to be outside. And then you also have that regular purple being very healthy. Again, this is a swath that is including millions and millions of people from stretching from, again, Minnesota all the way now to the East Coast and the Mid-Atlantic as well. So that's ongoing conditions right now after multiple days. So why do we care about this? Well, in one sense, we have had improvements in our ability to clean the air in a lot of places across the United States going back the last several decades or so. All of that can be stalled by an increase in wildfire smoke. So our ability to clean the air, reducing pollution that can have positive health impacts can be stalled because of wildfires, an increase in wildfire smoke in other places. And this is just an image that shows that, where these are 30 different states where we've seen that smoke has stalled the air quality gains from 2000 to 2022. And one of those where we've seen the influence actually even reverse itself is one of the states that's currently under the gun right now with all of this wildfire smoke, and that's Michigan, where we've seen incredibly poor air quality in Detroit and Lansing and other communities across that entire state. Right now, if you're going to take a look at places across the entire world with the worst air quality, unfortunately, it's here in the United States.
Yeah, thanks, Tom. And just a couple pieces to that too. I was talking with some meteorologists in Milwaukee. They said this is the worst air quality that they've ever experienced. What they experienced over the last 24 hours being up to that hazardous level. And one thing to consider, there is the final match for the World Cup that is slated to be played in New Jersey on Sunday. Some air quality benefits, as the pattern kind of shifts as we go through the weekend, but air quality is on the mind of a lot of folks for that match on Sunday. So something to think about. Okay, so on the bottom side of this high pressure, let's talk about the other impacts because again, everything's moving in this clockwise fashion. So there's another big story that's unfolding, and that's the flooding that we're experiencing here in Texas. I'm located just a couple hours to the east of where the worst of the flooding is happening here in the Lone Star State. So we wanted to help kind of frame that as well and tell you that climate fingerprint piece too. So one thing that we know, this is very, similar area, similar topography, that this rain continues to just fall round after round in heavy batches over Texas that happened last year with the July 4th floods over the Texas Hill Country. So much like what we're talking about with these fires, we know that the weather pattern itself, a stuck weather system over the western side of Texas, a stalled front to the north earlier this week, those are the reasons that we're seeing the rain. We're not saying that climate change has created the rain, but what we understand is that the fingerprint of climate change here is that it is making that rain heavier. It's making it come down harder. So what was already going to be a very significant rain event now is a little more significant because we have this influence of climate change. So what I'm showing you here is basically where the moisture is coming from that is feeding the weather system sitting over Texas. So you can see these arrows over the Caribbean, passing over the Yucatan Peninsula, and then up through the western side of the Gulf of Mexico. That's the moisture supply at the lower levels that's being pulled in, this very moist tropical air mass that the National Weather Service has been talking about for days, that as these rounds of rain come together, this is what it's being tapped into. And this is why we're seeing such fast rainfall and such heavy rain. So I want to bring you back to that attribution piece. This is the Climate Shift Index Ocean. So what we're doing here is understanding the fingerprint of climate change on sea surface temperatures. This is from July 15th when one of the heaviest rain bands started picking up around Uvalde and then back into the Kerrville area. And these reds that you see, this is where water temperatures are more likely. We're sitting at about 86 to 88 degrees for water temperatures. That's August, September type of heat in the Gulf of Mexico, running about 2 to 3 degrees above average for this time of the year. So those ocean temperatures have been made as much as 40 to 100 times more likely because of human-caused climate change. And you might be thinking, okay, so how does this tie into the moisture that's feeding in? Well, a couple different things that we know is that warmer oceans allow for more evaporation. So think about that as more moisture, rain-making moisture that's going into the atmosphere and waiting to be unlocked. I like to think of it like a bucket. So we're filling that bucket a little bit more, and these weather systems, these rounds of rain, are tipping that bucket. The thing that we all learned in physics in high school, some of us may have forgotten about, but essentially the way it works is for every 1 degree Fahrenheit of warming, we can hold on to about 4% more water vapor, 4% more of this rain-making moisture in our atmosphere. And then just kind of looking at the spot in Texas, we understand that rainfall rates have increased. This is just to the west of San Antonio. San Antonio itself over the last 50 to 55 years has experienced about a 6% increase in rainfall intensity. So rainfall rates, how fast that rain is falling from the sky. That may not sound like a lot, but think about our infrastructure and the way we build our cities with a lot of concrete. The infrastructure was built decades ago. It wasn't made for a climate where we're seeing these heavier rainfall events, where we're seeing the rainfall faster. When you look to the north of where some of this rain has fallen, San Angelo, Texas has increased near 30% in terms of rainfall rates just over the past 50 to 55 years. So this area of Texas, we understand that more often than not, they're seeing drier days. It's hard to get rain, and it's increasingly harder to get rain in this part of Texas. But when the rain is falling, it is falling harder, and it's falling over a landscape that is idyllic in nature. The reasons that we go there for camping, to take some days off, to enjoy nature, is the same reason that it's so dangerous. You've got the limestone canyons, and you've got the ability for this heavy rain to come rushing through that limestone that it can't be soaked into. So this is a look at the past week in terms of how much rain has fallen. And you'll notice here near Uvalde, Sabinal, Concan, This brownish, whitish area, this is where anywhere from 25 to 30 inches of rain has fallen since Sunday. And just yesterday, we saw that big bullseye pop up around Kerrville, causing the flooding on the Guadalupe River, as well as the Frio River coming out of Concan and then down through Uvalde as well. So again, this is that area of Texas where we've seen this 5 to 30% increase in terms of rainfall rates. And then we can put a price tag on that. So it helps us really understand. And this is also a portion of Texas where annually anywhere from $1 to $10 million could be lost because of inland flooding, the flooding that we experienced last year, the flooding we're experiencing this year. And we know that with climate change, as our atmosphere continues to warm, holds on to that moisture, that we have the ability for this price tag to increase, especially as we continue building in the Texas Hill Country, and then just with the infrastructure that we're losing. And Tom, one thing I would add before I pass it on to you, we saw so much loss of native trees last year in the Texas Hill Country floods. Those trees were able to slow down some of that runoff. So this year's floods didn't have that same natural barrier because we did lose so much of that ecosystem to the floods last year as well.
Yeah, that's an important point to make, is that we do see these events kind of occurring so rapidly in year-to-year succession that you can have it be worse the next year because of it relating to previous impacts. Similar to how Shell showed that influx of moisture into Texas, we've also seen the southwest monsoon across southwest United States really kick in the gear. There's been flooding in a lot of places across parts of Arizona and getting into New Mexico. This is looking at the excessive rain outlook issued by the National Weather Service, the Weather Prediction Center, and it has been a very wet time. And a lot of this now, these areas too have experienced wildfires in the past several years. So now, not only when you have these flash floods in some of these previously dry places in Arizona, what they're also picking up is a lot of the debris from previous wildfires. So not only are you having an increase in the water and the rain and the damaging flash flooding, but what it's also bringing along with it is not great stuff as well. And this is something that is expected to continue. The southwest monsoon, looking at the more extended range forecast by the Climate Prediction Center, it looks to be, at least they're trending towards it being an above average monsoon season. Now, this is an area of the United States that's been stuck in drought for the better part of the 21st century. So in some shape, this is not the worst thing in the world that we're seeing a little bit of an increase in rainfall during this time of year, although it does come with that chance for increased flash flooding. And as Shell showed for Texas, that increase in heavy rainfall rate, that's also true for parts of the Southwest as well. That includes Phoenix and it includes Tucson as well, where we've seen an increase in these heavier rainfall events, even while, in general, precipitation overall has decreased across this region. Now, this does not mean that the area is going to get out of a drought. I think that's also a really key component. While it might be beneficial right now, it takes a lot more than one really wet monsoon season to break out the Southwest from a long-term water control issues. And there's a reason why, if we go back to the early 2000s to now, we've had years where we've had wet conditions across the Southwest. But often what ends up happening is the next several years after that, it goes right back to dry. So while this is a good news for some of those water areas, especially filling reservoirs, the long-term story still for the Southwest is a dry one.
Yeah, and Tom, one thing that stands out to me on this outlook, for rainfall up around Minnesota, we focused a lot on those wildfires in Ontario, but we know that there's a lot of wildfires burning in the northern parts of Minnesota. So we'll have to see how the rest of the summer continues, but not a great outlook up there as well. Okay, so we're going to open it up to Q&A, I think, here, Abby, but I just wanted to give you two opportunities. On the left-hand side, that is a QR code. It'll take you to our climate shift index. You can look at climate change's fingerprint on daily temperatures. Globally, you can look at sea surface temperatures as well as humid heat when we're talking about that health aspect. And then on the right-hand side, if you're not signed up for our Climate Matters, it's weekly, 52 weeks out of the year resources that drop into your inbox every Wednesday morning. We'll also share these links in chat as well.
Yeah, so the Q&A box is down at the bottom of your screen in the right corner. If you don't see it and click more, you'll be able to pull it up. Feel free to drop your questions in there and we'll answer them live or type responses. But in the meantime, I'll get us started with a few questions. One that we're getting a lot these days is what about El Nino? How is this impacting? Um, so yeah, maybe Tom can take that one and Shelley, you can jump in. So I'm sure that one will come up eventually.
Yeah, the one big question people get are asking literally about probably every event that's happened across the entire world is this El Nino? Are we seeing this to be El Nino? Now, El Nino is currently in place in the Pacific Ocean. It's currently impacting the atmosphere. It's expected to become a strong to very strong El Nino when it peaks in strength later on this winter. Now, its impacts on the United States during the summer are not that strong. So while we do have that El Nino in place and it is having impacts probably elsewhere, especially around the tropical Pacific Ocean, I would not look to El Nino for blame for this. What we're seeing is what I would say, Michelle, I'm curious your thoughts too on this, is that we're seeing a not untypical heat dome in the United States in the summertime that's been amplified by climate change. And we're seeing the repercussions of that where you're taking something that can normally happen that's basically now just been ramped up in a lot of different places. And you can see the end results of that.
Yeah, one of the things we saw with this heat dome, it wasn't just breaking temperature records here at the ground, but also for how strong it was in the atmosphere. So this is one of the stronger heat domes that we've seen at this time of the year. As we talk about El Nino, like yes, as Tom mentioned, this eventually will continue to add more and more to the extreme weather that we're experiencing. That's just what El Nino does. Being a Texan, the way I've been liking it is think about the weather that we're experiencing as a glass. And in that glass is tea, right? We love our sweet tea here in the South. That tea is climate change. El Nino is essentially the sugar that has gone into it. So it's adding to the impacts that we're seeing, but the underlying reason that a lot of this extreme weather is happening and it is made worse is because of human caused climate change. And then we're going to put on top of that some of the influence from El Nino as it continues to develop and get stronger into the wintertime.
Yeah, another question that I'm hearing is about this wildfire smoke from Canada. Um, is this the norm now? Is this how summers are? Should we expect to just experience wildfire smoke every summer in the US now?
Yeah, I can start on that one. The short answer is probably yes, right? We've seen it more and more, and we're understanding the link, especially between the extreme heat that Canada is feeling, along with the explosion of wildfires that we see. We know that most wildfires are started generally by humans or lightning. But those underlying conditions have to be there. Those warmer than average temperatures for an extended period of time, longer times of drought. If you look at the drought monitor for Canada, they're also experiencing a pretty significant drought in these areas. So those underlying reasons that we have the ability to have these tinder boxes, and then we see these fire weather days increase. So it doesn't mean that fires are going to start on those fire weather days, but we know that these days are becoming more common, that the conditions are there. And what happens is like we've seen this week where we see this explosion of wildfires, especially in the summertime. More and more, we're seeing this wildfire smoke because of the pattern we get during the summer season, drifting especially into the northeastern US, into the upper Midwest. So we're not going to necessarily, at least for right now, see it this bad every single year. But this is something that folks across the northern and northeastern side of the US, this is climate change. This is going to be something that becomes more common. And we're going to continue to see more of these air quality days be degraded because of it. And Tom, the last thing I would probably add here is talking with a lot of our partners, just talking with folks who live, especially in the upper Midwest. They always say like this is the time of the year that they get to be outside when the weather is more enjoyable. So this is the time that they get to be and experiencing the outdoors. But that timeline's becoming shorter and shorter as their air quality gets decreased during the summer months.
And one thing to remember, this area of Canada that's currently on fire is the largest intact forest in the world. About a quarter of the intact is the Canadian boreal forest. It stretches from Alaska, that border, all the way to Newfoundland in the Atlantic. So this is a huge forest. And if we're talking about another climate angle with this, is that is a huge carbon uh, sink, but also when you burn this much of intact forest, you also are releasing, unfortunately, a good amount of greenhouse gases from that. Another important point to note with these forests is that these fires are happening over very, very rural areas, almost impossible to get to by firefighters. Which means that if you create the conditions, the dry conditions for wildfires to expand, to start, when all you need is a spark in places that are incredibly remote, then unfortunately these fires are going to keep growing out of control and leading to there being more smoke. It's Canada's a lot of land in Canada, and these fires are taking place in a lot of places where it's just not easy to get to.
Yeah, I have another question here from one of the attendees. So, a lot of talk about the World Cup has focused on wet bulb temperatures. Is there a humidity signal with this system? So, if one of you wants to chat about the humid heat CSI right now, that'd be great.
Yeah, I was just looking it up. That's a great question. So, looking at the final match on Sunday, it doesn't look like there's a humid heat signal. So, generally, you would expect it to be about the same there in New Jersey. Now, for the match on Saturday with England and France down in Miami, there is a humid heat signal there. So, we know that once again, looking at some of the numbers, Miami was the city that we knew would be highly affected because of climate change when it came to performance impairing heat and humidity. That humidity is going to be a little thicker, even for a coastal city like Miami on Saturday, made as much as 10 times more likely because of human caused climate change. And you can find that on that climate shift index link as well.
And I'd say overall, in general, we've seen a significant number of World Cup events, according to our analysis, that are above that threshold where we see the heat beginning to impact player performance. I think it was 50 to 60 of the games, it's over half of the games so that had been played at the World Cup took place in conditions that were hot. So one of the hottest World Cups on record for sure.
I have another question about El Nino. Could a super El Nino suggest a longer fire season?
I think climate change can suggest a longer fire season, unfortunately. And I think that's probably the main driver behind it is that, yeah, El Nino might have that little extra boost, as Shell was saying, that little extra sugar in your sweet tea. But in general, the reason why we're seeing these longer fire seasons, not only in Canada, but especially across the United States, across the Western United States, is because we've seen the heat being able to last a lot longer and the conditions that are conducive for wildfires last longer.
Yeah, and Joshua, I added a link there to your question that you can look across the United States and see how much longer that fire weather season has gotten here in the US.
Yeah, and I have another question here about forecasting these extreme events, because they haven't happened before or been seen before. Therefore, there's not a lot of historical data in the models. How do we look forward at events like this, and how are we able to predict more extreme events?
Yeah, so I think this is one thing that's been filling my feed a lot on Instagram is meteorologists, especially in the northeastern states, talking about busted forecasts because they forecasted for temperatures that were going to be 10 degrees hotter and a blue sky day. So it really, first of all, I think shows us that you can predict the weather, but we can't predict the future, right? We can't predict that these fires were going to explosively grow the way that they did early this week. And so it was that wildfire smoke that actually kept those temperatures about 10 degrees cooler across the Northeast. Now, that being said, this was a very well predicted high pressure dome. We knew that it would be very significant. We knew that records would fall. We knew pretty much the cities where they would. So a lot of this comes down to we're still doing a pretty good job in terms of forecasting it. But when we see these extreme events, so again, I'm in Texas and I'm going to go all the way back a couple of years to something like Hurricane Harvey. We know that there was a climate change fingerprint to the rain there. When the forecast model was putting out 40, 50 inches of rain, you look at that as a forecaster and you say that there's no way, like this has to be wrong. And so what we really have to understand is when we see these extremes be forecasted by the forecast models, we have to understand that there is something different here. And that change that we've experienced is climate change. And with the records we saw this week, not only were they daily record highs, as well as record high minimums, so the warmest low temperatures of record, I looked it up. Just in the past week, we've had 418 record highs in the US, 360 of these warmest nights of record. But that also included all-time records. So a lot of what we hear a lot is it's summer. It's supposed to be hot. And the answer to that is yes, it is summer and it is supposed to be hot in a lot of these areas. But when you're reaching temperatures and shattering records that have held since the late 1880s for a lot of our cities, we know that this isn't just summer. This is something new, and we can put that fingerprint of climate change to them.
Yeah. We're at the 12:30 mark. So we'll maybe wrap up soon. I want to thank Shell and Tom for your expertise today and for everyone who joined. If you want to reach out afterwards, my email is in the chat. You can also find it online. It's avich@Climate Central. I would be happy to connect you with our experts, and all of the registrants will get a recording link afterwards. Shell and Tom, any closing words?
I would just say my email is available as well. You saw it there. So if you have questions or you're looking for resources or visuals, everything that we showed you here today is available to use for your reporting and your storytelling. But feel free to reach out. We're happy to help where we can.
Yeah, that's what we're here for.